Now let's talk about the square. This is also a parallelogram that is both a rhombus and a rectangle. So of course, because it's a rhombus, the four sides are congruent. Because it's a rectangle, the four angles are right angles. If we could draw in the diagonals, we can also show that because it's a rhombus, the diagonals are perpendicular, and because it's a rectangle, the diagonals are congruent, and because it's a parallelogram, of course, the diagonals are bisecting each other. So it's important to remember the square is a parallelogram, so it has all of the parallelogram properties. It's a rhombus, so it has all of the rhombus properties, and it's a rectangle, so it has all of the rectangle properties. Let's take a look at some examples. The diagonals of square EFGH intersect at point J. Given that GJ is 15, find the indicated measure. So remember, because a square is a rectangle, the diagonals are congruent, so we can mark them to be all the same length with the hash marks and mark that all of these segments are 15. Also, because it's a rhombus, we can mark that there's a right angle where the diagonals intersect each other. Also, because it's a rhombus, the four sides have to be congruent to each other. There's a lot of stuff we can mark in this picture. Let's not go too overboard, and let's read what the questions are asking us. What is the measure of angle EJF? Angle EJF. Well, because we marked our picture, we can see that this angle is a right angle, therefore it equals 90 degrees. FH. FH is this segment that goes all the way down, which is 2 of the 15s that we already marked. So we've got to put those together, 15 plus 15, which equals 30. How about FG? FG is this side right here. Now I know that all four sides are congruent, so I'm looking for any information along the other sides, but I don't have any. But since the diagonals are perpendicular, there's a right angle here, and therefore I have a right triangle. Not only is it a right triangle, but it's an isosceles right triangle, where two of the sides are the same length as 15, and therefore using my special right triangles, the hypotenuse has to be 15 square roots of 2. That's the easy way to do it. If we don't remember the special right triangles, we can always use Pythagorean theorem, c squared equals a squared plus b squared, c squared, c being the hypotenuse, the one that we don't know yet, and a and b being the two congruent legs, 15 and 15. We can solve this the normal way with Pythagorean theorem. Either way, we still get to c being 15 times the square root of 2, or an equivalent decimal answer if that's your choice. If the slope of FG is 1/3, FG is this side. Notice that's the slope and not the length. Length is different than slope. So if the slope of FG is 1/3, then the slope of HG, this side right here, if the slope of that side, what is the slope of that side? Well, notice that these are sides that are right next to each other, where in a square, all four angles are 90-degree angles. Therefore, these two sides are perpendicular, and therefore the slopes are opposite reciprocals. So this is positive 1/3, opposite reciprocal, negative 3/1, or just negative 3 to be simpler. Let's take a look at comparing all of the types of parallelograms. Each figure is a parallelogram. Identify the special type. Is it a rhombus, a rectangle, or a square? And explain your reasoning. Now it's important that we know that each figure is a parallelogram because we are given limited information in the picture. It looks like that only two sides are congruent, but because it's a parallelogram, the opposite sides have to be congruent. So if that has a hash mark in it, the opposite side also does. Similarly, that one and its opposite side must be congruent as well. So with that, we notice that all four sides are congruent. When all the sides are congruent, that makes a rhombus. This is part of explaining our reasoning, is writing the characteristic that we see. So all sides are congruent, that makes a rhombus. But hang on a minute before we say this is a rhombus, we also have a right angle. And in a parallelogram, the opposite angles are congruent. So this is also a right angle. And the consecutive angles are supplementary. So 90 plus 90 is 180. That's also a right angle, and therefore so is this one. So now we see that all of the sides, not all of the sides, we already did that one, but rather all of the angles are congruent or 90 degrees, and that makes it a rectangle. Now we're not going to say it's a rhombus or a rectangle because if it's both a rhombus and a rectangle, then it's a square. This one is a square because it's both a rhombus and a rectangle. Let's take a look at the next one. Here we see a quadrilateral that has diagonals drawn in and the diagonals are bisected. Now the diagonals are not shown to be congruent, so we know this is not a rectangle, but the diagonals are shown to be perpendicular, therefore we know that this must be a rhombus. Why is it a rhombus? How do we explain our reasoning? Because the diagonals are perpendicular. Remember that upside down T sign is the symbol for perpendicular. So we could write out the long word if we wanted to, or just use that upside down T sign. And lastly, we have a parallelogram that shows one right angle. But remember, if it's a parallelogram, the opposite angles are congruent and the consecutive angles add up to 180. So 90 plus 90 makes 180, and we have four right angles. That's all the information we know. Therefore, the best we can say is that this is a rectangle. Our explanation is because all angles are congruent. We could, of course, say all angles are 90 degrees. That would be a valid reasoning as well. Thanks for watching.